Buenas tardes a todos y bienvenidos al taller de PTV, Shaping Mobility, en el Congreso de Ingeniería de Transporte de Burgos. En primer lugar, quería dar las gracias a la organización del Congreso y al Foro de Ingeniería de los Transportes por permitirnos una edición más, el tener este espacio, en este caso este espacio virtual de encuentro, al que venimos siendo fieles desde hace ya varias ediciones. Mi nombre es Ignacio Galindo, trabajo como responsable de servicios profesionales de PTV para la región ibérica y voy a ejercer de presentador en este primer taller. En anteriores ediciones, en otras ocasiones, hemos aprovechado este espacio como punto de encuentro de la comunidad de usuarios del software de PTV. Le damos voz a los clientes que nos han presentado trabajos singulares en los que han venido utilizando el software de PTV. En esta ocasión hemos querido cambiar un poco el formato y aprovecharemos el evento para tocar algunos temas de actualidad, así como para difundir líneas de desarrollo que consideramos más relevantes dentro de las actualmente líneas de desarrollo de PTV. Para ello, contamos con la colaboración de Luis Willumsen, socio fundador de Nomon, empresa puntera dedicada a la explotación de nuevas fuentes de datos para la planificación y gestión del transporte, entre otras aplicaciones, y sobradamente conocido en el ámbito de la modelización por ser autor, junto con el profesor Juan de Dios Ortúzar, de la obra de referencia de modelos de transporte. Luis, o Pilo, como es quizás más conocido, nos hablará precisamente acerca de este reto, ¿no?, de la modelización basada en nuevas fuentes de datos. A continuación tendremos a Sebastian Sielemann, es Product Manager en PTV, en el campo de la modelización macroscópica y responsable de algunas de las líneas de desarrollo más interesantes en Visum. Él nos hablará de los desafíos que imponen las modalidades de transporte compartido en la modelización. Después tendremos a Jochen Lohmiller, también desde Karlsruhe, que aportará la visión de la modelización desde la perspectiva micro, con PTV Visum, de la cual es amplio conocedor como Product Manager de esta herramienta. Y finalmente tendremos a Didier Scellier, que es director de PTV Francia y también de nuestra filial ibérica, que compartirá una presentación acerca de los desarrollos de PTV en el ámbito de la logística. La presentación de Pilo será en español, las siguientes serán en inglés y solamente me queda recordar que podéis dejar vuestras preguntas utilizando el botón que tenéis de preguntas y respuestas, que trataremos de responder a la finalización de cada presentación. Y os recuerdo también que después de esta sesión tendremos otra sesión de PTV a las 5:30, dedicada propiamente a las actividades de PTV en el ámbito de la academia. Pues, sin más preámbulos, le paso la palabra y el control de la pantalla a Pilo, si estás por aquí.
Muchas gracias por invitarme a hacer esta presentación que combina en cierta medida el trabajo que yo he estado haciendo en los últimos 30 años en modelación con el ímpetu que ha recibido el uso de Big Data en los últimos 5 o 6 años, donde también he participado como socio fundador de Nomon. Me voy a referir entonces a la más difícil tarea de formular y calibrar un modelo que esté basado, por lo menos en parte, en las nuevas fuentes de datos. Y estos son no solamente los datos de telefonía, sino en general otras fuentes de datos también. Entonces mi presentación tiene 4 partes: ejemplos iniciales del uso de los nuevos datos, la naturaleza de las nuevas fuentes de datos, qué hay que hacer para mejorar el modelo, en particular utilizar la función de datos para poder refinar los modelos, y finalmente obtener algunas conclusiones. Quería darles 3 ejemplos de cómo se está usando o se ha estado usando el Big Data para calibrar y desarrollar modelos. El primero es un ejemplo de PTV. Ya más de un par de años, como parte del Virtual Mobility Lab de Barcelona, tuvimos un proyecto en que colaboramos, Nomon en ese tiempo se llamaba Kineo también, y PTV y el Mobility Lab de Barcelona, para desarrollar un modelo orientado a modelar movilidad como servicio, mobility as a service, que era en ese momento una nueva tarea y había que desarrollar nuevas formas de hacerlo. Se utilizaron los datos de telefonía que los extrajo y procesó Nomun para obtener matrices de viaje, una asignación normal, y luego PTV usó su MaaS Mobility Services para producir la micromodelación de estos servicios. Un segundo ejemplo, continuando con Barcelona, que es un lugar muy popular para desarrollar este tipo de modelos, desarrollamos un modelo basado en actividades. Es algo que se ha empezado a hacer en los últimos también 5 años en Europa, un poco antes en Estados Unidos. Y la idea es interesante porque en realidad la primera parte del procesamiento de los datos de telefonía es precisamente identificar momentos en que la persona se queda en un lugar, que realiza una actividad, que puede ser dormir donde vive. Y eso permite que nosotros construyamos los viajes como una conexión entre distintas actividades. Entonces parece muy natural utilizar esta muestra de datos de telefonía para desarrollar este tipo de modelos. En este caso estábamos tratando de estudiar diferentes políticas para restringir o mejorar las condiciones de tráfico dentro de las rondas. Hay un paper al respecto que ustedes pueden buscar y bajar que detalla mejor cómo se hizo este proceso y cómo se utilizaron los datos de telefonía. Y probablemente el proyecto más grande en este tipo de aplicación es el modelo actual de Londres, que se llama Motion, en el cual yo no tengo ninguna participación. Utiliza matrices origen y destino de telefonía móvil, que son de hecho proveídas por Telefónica en ese caso, pero también otros Big Data, Strava para modelar las bicicletas y la tarjeta inteligente Oyster, que utilizan tanto buses como el metro y parte de ferrocarriles también. Este es un modelo en gran escala y muy importante, emblemático en el mundo de la modelación realmente. Sigue siendo, a pesar de todo, un modelo fundamentalmente agregado, tiene solamente algunos aspectos desagregados. ¿Cuáles son estas nuevas fuentes de datos? Son huellas digitales. Huellas digitales que vamos dejando mientras usemos o no el teléfono móvil, cuando validamos la tarjeta inteligente, cuando usamos algún navegador en un coche. Esos son dispositivos que se mueven con las personas o con el coche y van dejando sus pequeñas breadcrumbs, su pequeña huella digital en forma casi continua. Pero también hay sensores que se utilizan en distintas partes de la red, como cámaras, sensores de Wi-Fi, sensores de Bluetooth y aún drones, que también permiten obtener información, en algunos casos bastante desagregada y bastante local, por ejemplo, un drone para ubicar la matriz de movimientos en una rotonda de gran tamaño. Todos estos tipos de datos se usan, yo diría, los 3 países líderes en el mundo en este momento para usar este tipo de datos son los Estados Unidos, Gran Bretaña y España. Otros países están empezando a usarlo, pero más en forma experimental. La telefonía, los datos de telefonía tienen ventajas importantes sobre las encuestas tradicionales. El tamaño de la muestra comparado con una encuesta domiciliaria es un orden de magnitud mayor, por lo menos. Es una recogida de datos pasiva, no hay que preguntar nada y por lo tanto no nos pueden dar una respuesta que sea ligeramente misleading, que sea ligeramente no veraz. Se observa lo que las personas hacen. La información está actualizada. En España tenemos información desde el día de ayer, hacia atrás por 4 años. Y esa es información 24 horas al día, 7 días a la semana y 365 días al año. Y hay una pequeña reducción de costos que generalmente no enfatizamos mucho. Sin embargo, los datos de telefonía no son suficientes. No entregan algunos datos claves, por ejemplo, la posesión de automóvil o motocicleta, si tiene o no la persona una licencia de conducir. Permiten identificar pocas actividades. Por el momento tenemos restricciones prácticas de cuántos tipos diferentes de actividades podemos identificar, en parte porque la celda, que es nuestra unidad geográfica de análisis, puede cubrir más de un tipo de uso del suelo, entonces no somos capaces de distinguir. Solamente distinguimos fundamentalmente el hogar, el trabajo, por la longitud de tiempo que la persona permanece allí, y otro tipo de viajes, pero no mucho más. Tampoco tenemos suficiente resolución espacial para identificar con certeza el modo de transporte. Incluso nos cuesta separar el coche del bus de la motocicleta en lugares urbanos con congestión. Y además de esto, porque la base de análisis es la celda de telefonía, que es pequeña en áreas urbanas y más grande en áreas rurales, pero se pierden algunos viajes cortos. Los viajes que son dentro de una celda son invisibles para nosotros. En general son de viajes del tipo intrazonales en un modelo agregado. Y por eso necesitamos la fusión de datos para superar estas limitaciones. Como un ejemplo, por otro lado, la ventaja enorme que tienen los datos de telefonía es que producen matrices origen y destino mucho más ricas, mucho más completas en representar el real movimiento de las personas en una ciudad. Aquí estoy comparando las matrices origen y destino bastante agregadas al nivel de 45 macrozonas, o son de hecho municipios en el caso de Santiago de Chile, en que uso el color para indicar el 0, es un azul oscuro, el mayor número de viajes es el rojo, el amarillo y verde son puntos intermedios, y como ven, los viajes intra-macrozona son la mayoría, son los valores más grandes. Esta es la encuesta domiciliaria de Santiago, expandida al mismo nivel que la matriz expandida de telefonía, que es esta. Como pueden ver, no hay ninguna celda vacía y corresponden más o menos los colores azules con los colores verdes en general, o sea, donde nosotros sí tenemos viajes del orden de 1.000, 2.000, 3.000 viajes al día, estos son viajes diarios, y eso realmente produce una matriz que es mucho más rica y más fácil de aplicar en un modelo. Tenemos menos problemas de calibración de un modelo porque la matriz inicial es mucho mejor. El problema es que eso es una matriz inicial de movilidad general, de personas, no es de vehículos. Y para calibrar un modelo en general necesitamos viajes por modo, y en el caso de que estemos calibrando con aforos necesitamos viajes en vehículo, no viajes de personas. Entonces la pregunta es ¿cuánto puede aportar la fusión de datos para mejorar, segmentar mejor la matriz de movilidad general para ayudar a calibrar el modelo? Primero que tenemos que reconocer es que nuestras matrices de viaje están construidas no a partir de un día, sino a partir de un mes de datos. Hacemos un mes de inspección de datos longitudinales de todos los teléfonos que están siendo utilizados durante ese mes en el área de interés. Y eso nos permite determinar con bastante seguridad, con mucha certeza, dónde vive la persona y dónde trabaja la persona. Eso puede haber variaciones día a día, pero en general, teniendo 30 días visibles, podemos decirlo con mucha más certeza. Y además podemos identificar qué actividades son frecuentes y qué actividades no son frecuentes, lo cual nos permite tener una impresión sobre la frecuencia de viajes. Y el análisis longitudinal, durante un mes, nos permite también una clasificación parcial de vehículos. ¿A qué me refiero? Nomon ha desarrollado algoritmos para poder identificar el conductor profesional, es decir, el conductor que está la mayor parte del tiempo conduciendo. Hay dos tipos de este. Uno son los taxis y Ubers, servicios de ese tipo, y el otro son los camiones de carga. Y este análisis se basa en el patrón de viajes durante un mes, porque ese tipo de usuario viaja muchos más kilómetros por día, se está moviendo casi continuamente todos los días, y mucho, permanece en un entorno urbano fundamentalmente, excepto a lo mejor durante 1 o 2 días en el mes, y eso nos hace que pensemos que sea un taxi. O visita centros logísticos, puertos y aeropuertos, en ciertos horarios especiales, hay mucho viaje de noche, que nos hace pensar que, o hemos podido determinar que esos son camiones de carga. Esta clasificación no es perfecta, pero captura un alto porcentaje de los viajes de este tipo. Hay un pequeño rango de error y en realidad todo análisis de datos de telefonía es un análisis probabilístico. no es un análisis determinístico. Debemos completar esto con otros datos, en particular aforos, y cuando estamos combinando datos de distintas fuentes, tenemos que reconocer que eso es algo que hemos estado haciendo por 20 años o 30 años. Nuestros modelos tradicionales utilizan fusión de datos para combinar matrices generadas por las encuestas domiciliarias y las encuestas de interceptación, y para el modelo encuestas de preferencias declaradas que nos dan valores de ciertos parámetros como el valor del tiempo. En el caso de la telefonía, también debemos utilizar diferentes fuentes. La más importante es el aforo de tráfico clasificado. Yo creo que nunca vamos a poder prescindir de esa fuente de datos. Pero también utilizamos mapas, en particular OpenStreetMap, pero otras fuentes de mapas, y rutas de transporte público para poder hacer map matching y localizar más exactamente el usuario en un lugar del mapa y no en una celda, digamos. Eso nos ayuda a identificar mejor. Tarjetas inteligentes de transporte público son muy útiles cuando existen como un modo mayoritario de uso del transporte público, pero también podemos usar encuestas antiguas que han sido hechas anteriormente o simultáneamente con el uso de teléfono. Y los tiempos de viaje generalmente los obtenemos de Google o de Inrix. Y el problema es tratar de obtener la mejor matriz de viajes con la segmentación que necesitamos, por lo menos por modo. Y aquí yo quisiera llevarlos hacia atrás a un modelo que desarrollé yo hace probablemente 35 años atrás para estimar matrices de origen y destino con aforos de tráfico, utilizando la maximización de la entropía como una forma de identificar la matriz más probable. Y eso era un problema de programación matemática, una función objetivo sujeta a restricciones. Si enriquecemos la función objetivo e incorporamos el modo de transporte también, y en las restricciones incorporamos restricciones de todo tipo, como pueden ser los aforos clasificados por modo de transporte, datos de etiquetaje de boletos vendidos, otro tipo de información, de la idea de que la partición modal de la ciudad debe ser en este rango. Todos ese tipo de restricciones nos permiten obtener una mejor estimación, y eso es algo que hemos venido haciendo en los últimos 2 años con bastante regularidad, una mejor estimación de las matrices origen y destino por tipo de vehículo que está en uso. Los invito a explorar esta idea de maximizar funciones de entropía sujeto a restricciones, en que las restricciones son agregadas, pero la maximización de la entropía es al nivel más desagregado de origen, destino y modo de transporte. La solución de este problema matemático es una de las mejores soluciones en el sentido que es la más práctica, es el método multiproporcional de ajustes multiproporcionales. Hay aplicaciones prácticas de este approach, de esta metodología. La primera que hicimos en Nomon fue para Málaga, generar la matriz origen y destino y más adelante un modelo para Málaga, y en este caso fue fundamentalmente la fusión de 3 fuentes. Los datos de telefonía, se llaman CDR, Call Detail Records, la tarjeta inteligente de transporte de Málaga, que permite identificar por lo menos el punto de subida y la línea del bus en la cual se subió, por lo tanto sabemos la dirección en la cual se mueve, y aforos. Los aforos siempre son particularmente útiles. Pero en realidad había más fuentes de datos. Obviamente necesitamos los datos sobre la red de transporte público, y también ha habido simultáneamente algunas encuestas de opinión y algunas encuestas de preferencias que también fueron utilizadas, además de los datos de telefonía y los datos de tarjeta inteligente, para obtener las matrices de origen y destino. Y como siempre, el proceso es la parte crítica. El proceso es la parte delicada, no el dato original. El proceso parte por reorganizar los datos y limpiarlos, porque los datos contienen errores, inevitablemente. Y luego desarrollar algoritmos que refinen esto, identifiquen actividades, identifiquen momentos en que la persona se detiene, y conecten estas detenciones con viajes y generen, por eso, tours. Por lo tanto, los datos de telefonía también no solo son útiles para crear modelos basados en actividades, pero también modelos basados en tours, en circuitos. Y desarrolló los algoritmos en el caso de la tarjeta inteligente para estimar el lugar de bajada de la persona del bus, donde desciende, en función del siguiente viaje. El siguiente viaje refleja una subida y con un modelo probabilístico nos atendemos a cuál es el paradero más probable donde la persona se debió haber bajado. Y luego expansión de la muestra. Y se generan los indicadores tradicionales como ser una matriz, otra vez una matriz de movilidad y la matriz de transporte público en este caso. Más recientemente hemos desarrollado con empresas consultoras el modelo de transporte de la isla de Tenerife. Y aquí lo que tiene interesante este proyecto es que si bien habíamos producido originalmente ya una matriz de origen y destino para Tenerife, se utilizó esa matriz de origen y destino para diseñar encuestas adicionales, pero cuyo tamaño era solamente el tamaño necesario para responder a las preguntas adicionales, como sea la tasa de motorización, la posición de licencia, no para producir matrices de origen y destino. Y esto permite ahorros importantes en el tamaño de la muestra y, por lo tanto, en el costo de la campaña. Como conclusión, quiero decirles que, ciertamente en mi opinión, los datos de telefonía móvil bien procesados, y esto es crítico porque no todos lo hacen bien, ofrecen un valioso recurso para mejorar el realismo de nuestros modelos, incluso modelos basados en agentes o circuitos tours. La fusión de datos de telefonía con otras fuentes es fundamental. Los datos de telefonía por sí solos no son suficientes y mejoran la segmentación de matrices y facilitan la calibración del modelo. Pero aún así es necesario tener encuestas domiciliarias, porque hay que obtener otros detalles que ya he mencionado y poder validar también los resultados de las matrices de telefonía para saber si la distribución de longitudes de viajes es similar o válida. La óptima combinación de encuestas y datos de telefonía es un problema nuevo, pero es un problema nuevo e interesante porque debe bajar los costos del trabajo de campo y lo cual nos permite designar más recursos a la modelación y sobre todo a la planificación y a la predicción del futuro. Quisiera mencionar para cerrar que se están explorando en varios países, en este momento estoy participando en un proyecto en Chile, el uso de aplicaciones para reemplazar la encuesta domiciliaria. En Chile estamos utilizando una aplicación que se llama X-Inc, que fue desarrollada por el MIT, y esto ofrece otra oportunidad más para fusionar datos de distintas fuentes, en este caso datos de una aplicación que no solo da seguimiento a las personas, sino que también es capaz, con un cierto grado de certidumbre, con cierto grado de confianza, de estimar el modo de transporte utilizado en base al acelerómetro y otros sensores que existen en un teléfono inteligente. Con eso quedo con ustedes. Muchas gracias y atenderé las preguntas más adelante.
Muchas gracias, Pilar, por tu presentación.
Ahí estamos.
Me parece que, bueno, la invitación venía de ahí, ¿no? Nos parece que es un tema totalmente de actualidad y al que se están enfrentando todos los modelizadores actualmente que recurren a estas nuevas fuentes de datos y, bueno, nos parece muy oportuno el tener tu participación y esta presentación. No veo en la ventana de preguntas y respuestas, quizás, como vamos, tenemos un programa bastante ajustado, vamos a seguir con la siguiente presentación y seguimos atentos a esa ventana de preguntas y respuestas, quizás al final de la sesión aparece alguna. Yo tenía algunas preguntas, pero bueno, creo que han sido brillantemente respondidas durante la presentación. Okay, now I will change to English. Better, Sebastian? To introduce the next speaker, who is Sebastian Sielemann. As I previously said, he's product manager in PTV since 2005 and responsible for new developments of our macro modeling platform, PTV Visum. Sebastian, please, you can proceed with your presentation?
Thank you, of course. Okay, yeah, I believe you can see my screen right now and hear me. Yeah, good afternoon, everyone. If we are talking about future mobility and new mobility solutions, autonomous and connected driving, mobility as a service are the buzzwords everyone is talking about. But what if those buzzwords become real and broadly used by the public? So let us talk today about this new mobility concepts. New mobility concepts are most times defined that they're working without exclusively possessing a vehicle. Those concepts are not new. They are around for 25 years, but the change in lifestyle and digitalization empowers them. The main two concepts are vehicle sharing, which is broadly available in many cities with these e-scooters, bike, and car sharing. And today we will talk a little bit more about ride sharing, which is also already available, but still in a smaller scale. So systems where people share at least a part of their journey together in one car at the same time. The question is now how urban mobility will change. How sustainable are those modes, and how the systems are used by the user, and does it compete or extend the existing public transport? And yeah, the promises are appealing. Here I've got a post from HireCar. They promise less cars, less congestions, less air pollutions. It's about conserving non-renewable energy sources. And the question is, can these promises be kept? Experience from US, especially in San Francisco, seems to draw another picture. They talk about congestions by ride sharing and capacity loss on the street. But how can this be? To prevent this experience some US cities had to face, it's crucial to simulate new traffic systems in your city and environment, to estimate the effect for the user, for the operator, but especially for the public in your city. And here at the side, you see some screenshots from our software, PTV Visum, which includes a dispatcher algorithm to simulate ride-sharing systems in a macroscopic model. And this is most helpful to check the goals for such a system beforehand, to be efficient and sustainable. So let us talk about efficiency, which means do as less as possible and gain the most of it. What could be a good measurement for efficiency of ride-sharing systems? Yeah, we should take those detours into account. The vehicles have to do to pick up or drop off other passengers. We should gain for a high pooling rate. Many passengers using the same vehicle at the same time on the same path. And we should minimize the empty mileage ratio, so the percentage of mileage where no passengers is on board. So yeah, how we can put this into a simple equation, and then we can look at these detours, and the detour can be calculated as the passenger mileage requested, so the ideal travel time for each passenger, and the passenger mileage which is performed. The pooling rate Yeah, the pooling rate is the passenger mileage performed divided by the vehicle mileage occupied. And the empty mileage ratio is the vehicle mileage occupied divided by the vehicle mileage in total. And when we put this again into an equation, yeah, we can cancel out those passenger mileage performed and this vehicle mileage occupied, and we end up with a very, very small formula. Passenger mileage requested divided by the total vehicle mileage, which is a very, very good indicator for your system efficiency. But how to calculate those numbers? Yeah, it's easy if your system is already in place. Then you have the number. It's easy, but it's too late. So modeling such a system beforehand gives you these numbers before you implement the system. Yeah, looking at the system efficiency, what's the system efficiency for the private transport? So the normal car traffic. Yeah, the detours, you don't do detours in your own car unless you are searching for parking lots. So it's a little bit less than one. Searching for parking lots is a factor there. And the pooling rate is in Germany, it's about 1.36. I would believe it's something similar in Spain. And the empty mileage ratio, yeah, your car shouldn't do empty mileage. So you end up with a result between 1.3 or 1.36. And if your ride-sharing number is below that number, there will be more traffic on the street than every passenger using it would have chosen to go by the car at their own. And I saw some systems didn't pass this simple tests. So, but what's the ideal future? How can we improve the efficiency of such ride-sharing systems? Yeah, we should aim for maximizing the pooling. We should minimize the detours and, of course, the empty mileage. One way is, of course, to ask the passengers to be more flexible in their departure time and let them the specific departure time before. So this will lead to better time pooling and the order of the passengers. And yeah, maybe ask the passengers to walk to dedicated pickup points. This would lead to better spatial pooling. You can have a system of hubs and access then. And you should operate vehicles with more seats, of course, which can then cope with the pooling rate you hopefully reached. Yeah, but if you're successful, congratulations, you solve the problem, but you're operating a conventional public transport system. Yeah, so even an efficient ride-sharing system does not have to be a sustainable system. It's a matter of who are using it. And what mode have they used before? The expected mode shift have been that the car users will use the ride-sharing system. And this is data from US. But the revealed mode shift is that public transport users who are already used to share the vehicle will shift due to the higher flexibility. And even worse, real sustainable modes like walking and biking will be motorized afterwards. And this is not a US problem. This is data here from Germany showing the same results. just a small percentage of ride-sharing users have been using cars before. So not wait for the revealed modal shifts, but estimate this beforehand. Use the power of a traffic model. In the mode choice step of a demand model, you can include the new mobility services to compare the skims and to estimate the mode shift, which will be in your city afterwards. And yeah, what are the key takeaways, the key experience of the last projects? Ride-sharing systems works most efficiently if the demand is high and the area is densely populated. And of course, private operators tend to operate exactly there. But there, also, they compete with public transport, bike, and more sustainable modes. And this leads to congested cities and environmental damage. But ride-sharing is more flexible than public transport. And this is not a coincidence that it is used by the customers. So you may gain for harness the power of ride sharing by maybe regulation for concessions and use them to improve the accessibility of public transport, and consider maybe replacing low demand feeder buses with ride sharing systems. It might that you have to subsidize the operator to do this and implement their service as just as a feeder for the more efficient system, the public transport. And exactly this has been done in Berlin in the Public Master Plan 2018. The first paragraph for this new system was titled by "Does the new offer serve the public transport interest?" And they are looking for the same indicators we are looking for. So it was reduction of traffic volume, promote the climate and environmental protection, and increase accessibility. And they come up with areas where accessibility of public transport is bad and where such systems really can help, ride-sharing systems can help, but they just gave concessions to operate in there. And even in the city center, there are areas where those services can be useful because the streets was not suitable for buses. And for this, of course, ride-sharing systems are useful. So with this very short presentation, yeah, I will end my presentation and happy to answer questions if there are. Otherwise, Ignacio, it's up to you again.
Thank you very much, Sebastian. I think it's a very interesting reflection about the role of this new mode of transport in cities, and yeah, the need to think carefully how to implement or to allow them in our cities, and yeah, the role that simulation and modeling can play here. Again, I don't see any question yet in the window. It is still here, so we can continue, and then if there is any question, we can answer at the end. Well, I will make one question, Sebastian. Is it possible, I will say that way, is it possible to implement this mode of transport ride sharing in a demand model. Can I have your comment on this?
It's the new modes in the demand model.
Exactly, as an alternative mode of transport within a demand model.
Yeah, it is possible because you can aggregate all those single trips of the passengers, and so you can calculate the perceived journey impedances, and you can compare this to all other modes, and so you can calculate the mode choice of to this modes.
Okay. Thank you for your answer, and I will change now, and we will travel from macro to micro approach with Jochen Lohmiller. Jochen is product manager like Sebastian, but in the field of microsimulation, being responsible for the roadmap of current and future developments on PTV BC. Jochen, please, you can proceed with your presentation.
Thank you very much, and welcome also from my side from Germany. As a German who is interested in football as well, I feel with you Spanish people. We suffered a little bit more the European Championship. Very unlucky yesterday. Yeah, but today the topic microsimulation. In my presentation, I will mainly explain why you should consider simulation in general, and then specifically on microsimulation. And of course, simulation always in the context for transportation infrastructure planning. That is, of course, guaranteed in that conference. So ultimately, it's about the decision to take what and how and where to build or improve our transportation infrastructure. What do we do? And that brings a lot of questions. So what is the optimal design? How do we control traffic? Is it signalized, adaptive, coordinated, public transport prioritization, or even unsignalized? What is the best option? Do we need to use intelligent transport systems, speed limits? These questions. Is the design also suitable for the future? So when building, we often plan for decades in the future. So how will the population change? Are there some planned regulations in the city? What Sebastian just explained, how would ride sharing, autonomous vehicles, how will that maybe impact a city in the future? Then what is the impact on all road user? And specifically, more and more cities are looking now, the focus goes away from car-oriented planning into looking how will that affect also other modes of transport, like cyclists, pedestrian, specifically also public transport. Air quality is a topic in many cities, so we should also consider that, and noise, so all the pollution who comes from the transportation system. And the question is also, is the money well spent? Maybe there's a perfect solution, but it's extremely costly, and maybe there's a better, a not so optimal solution, but much cheaper. So that are decisions to take in the end, considerations. And for that, we require evidence. So we need to have an understanding on the impact of changed supply first. Of course, you may know that if we increase the capacity, often that leads to more demand because rerouting or mode shift. We need to, of course, have understanding of the traffic fundamentals, how it works. And that includes basically the first bullet points. Safety topic we need to consider. So we need to know and estimate how a certain design will affect traffic safety. We need to know the regulations, might be obvious, but we need to know the local traffic rules. Interaction with that, I mean more how does a certain infrastructure have an impact on the neighboring junctions, intersections. And we need to know specific local conditions, behavior. So that's always very important. Maybe just because why is there a peak at 6 p.m.? Example, maybe a bakery have 50% discount and everyone wants to get something, I don't know, a bad example, but there are sometimes very specific behaviors and conditions which should be understandable for the project. And then in the end, it's about what is the most cost-effective approach. And basically, there are two approaches. So some analytical approach, like a highway capacity manual, you don't use simulation at all. You just do some calculations, or you use simulation with different resolutions, macro, meso, micro. So to answer that, you need to know what is the needed accuracy and sensitivity. So what is needed to take a solid decision? What influences the traffic performance? Do I need the detailed look, or it's a rather standard intersection? What is the available data is the question. Of course, for both approaches, you need good data for the simulation as well as the analytical approach. Yes, and as the example, you see the two pictures on the right. First, upper one is a roundabout, and the lower round is a signalized intersection. It's a simple question. What do you need for designing that infrastructure? Roundabout, there's low sensitivity, so the behavior is not really relevant for the design. Well, of course it is, but not so much important. Saturated conditions might not be so important. It's clear what happens with saturated decisions. You might not have spillbacks on other junctions from that roundabout. Even if you think far in the future, how will autonomous vehicles drive in such a framework, might be not so sensitive to how you need to design the set. So that's maybe a clear analytical, so you can design this roundabout without the need of simulation. But if there is the lower end, the signalized intersection, very complex, like behavior, might have a huge impact on the throughput of this intersection. There's a lot of interactions between the different junctions here. There's like something like 50 meters ahead, there's another intersection. And signal phasing and timing is, of course, very relevant. Saturated condition, there are spillbacks and so on. And that might be a project where you need to have simulation to answer the question. So the main benefit for simulation is you verify. So verify your assumptions. How do your assumptions change the outcome? The simulation and specifically the model will help you to communicate your work. It helps you to understand why do I have this high delay at this approach at the intersection. You look into the model and may be able to understand why. You may detect unaware issues. So think of something you're not aware of, and that might pop up in the simulation results, and then you dig deeper and you may understand it. And of course, you can compare different scenarios to find what is the most effective way in designing and solving a certain issue in your transportation network. Decision support between different variants, looking at key performance indicator, comparing, and evaluate also the impact of certain assumption. You can play around, okay, what if I have autonomous vehicles function like that? What if I have 20, 30, 40% at a certain time point, and how will then this operate? This is possible, but rather easy with simulation. I'm not saying this is not possible analytically, but simulation certainly helps, and specifically detect the unaware issues. So these can be black swan events. So what is a black swan event? I want to elaborate a little bit on that. So a famous quote from Donald Rumsfeld is, there are known knowns, there are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. I think everyone can agree on that. There's something we don't know. But there are also unknown unknowns. And these ones, we don't know that we don't know it. We are not aware that something we are not knowing. So, and simplifying Nassim Taleb's original definition of a black swan event, what you can read in Wikipedia, a black swan event is a event that is a surprise to the observer. It has a major impact, and after the first recorded instance of the event, it's rationalized by hindsight. It could have been expected. Let me just explain that. So there are things, so on the left-hand side, there is knowledge here. So we know, and sometimes we are aware of it, and sometimes we're unaware of it. But then there is things we don't know. And we are aware that we don't know some things, but we are sometimes not aware that we don't know some things. And then for a project, there could be different outcomes. We do something right, we do something wrong. So, and looking at these different boxes, first one is lower left. So it's the ideal case of planning. We are aware that something has an impact, we know about it, and we do it right. That's the first box. The second box is we are aware, we know it, but we do it wrong. That is paradox. That's criminal in acting like that. Then there's the other box. We don't know, but we are aware, and we do it right. So we are aware, we don't know exactly what will be the outcome. We just do it. We do it right. This is luck. If we do it wrong, we know we don't know it. We are aware of it, but we do wrong. That's bad luck. Then there's things we know, but we are not aware of it. That we know it. That is routine. If we do it right. If we do it wrong, basically also kind of bad luck, but it's that you can say it's careless. So there is a mistake being made. And then on the unknowing part, if we are not aware that we do not know something, but if we do it right, that is luck. And if we do it wrong, that's unluck. So, and do it wrong is of course the critical parts. We should try to avoid these. If we don't know something and we do it right, you could say it's acceptable. It doesn't hurt. But of course, it's luck if we do it right or not, because it's unknown to us. And of course, we want to be on the lower left-hand side. This is something we are aware, we know, and we do it right. That's perfect. You could say, okay, we can also accept routine, something we are not aware, but we still know and we do it right. So, and these in the back, these are the black swan events. Again, it's kind of a surprise. So you are unaware of these, and it may have a critical effect, a negative effect in doing it wrong. So how should we work on that? So first, we should create awareness. So from unaware to being aware of it. And how can we do that? Simulation can detect unaware issues. So you see something, you haven't thought about that, but you see in a simulation model, in a result, that something appears. If known or unknown, but you create awareness. And then the second step is, of course, from the unknowing to the knowing. So you look at something you have not known, and you then realize that you look into, you don't know why it's happened, you talk to someone, and then you learn from it and create knowledge, and that helps, of course. But still, there's the option, do it wrong, do it right. But simulations also help to verify. So could be external or internal checks. And in the end, the simulation is a tool to help you to be on that part that you are aware. And I think that is a big advantage of simulation models. So now, coming to the microsimulation, why specifically doing microsimulation? What is the benefit of using simulation? Now, there are different decisions to take. There are many aspects in it, but I'll focus now on the resolution, macro, meso, and micro to distinguish. And first one, there's a definition in the Traffic Analysis Toolbox, Volume 3. Microsimulation can provide the analyst with valuable information on the performance of an existing transport system and potential improvements. However, microsimulation can also be time-consuming and resource-intensive activity. So it comes back again to the same question: what is the most cost-effective approach to meet the required output? Required output, often that is the level of service, but taking the relevant influences into account. So microsimulation is the most expensive way of doing it. the most complex. And we're saying that, I'm not saying that microsimulation is much more complex than macroscopic simulation or projects, but if you consider the same geographically way and try everything to do on a microscopic level, it's of course more complex and more expensive to do compared to macro. Typically, macro projects are much larger and they may be much complex compared to a roundabout model microsimulation. It has the highest accuracy and the most detailed performance measure. So what is the main benefit of microsimulation? First, you can model any geometry. So if that is of relevance, and especially for non-standard geometry, if you want to know something very in detail, so any analytical or other simulation resolutions, which may use some node link structure, they may not be the acceptable way of doing it. Of course, it depends again on the required output. But in microsimulation, you can take the exact geometry into account. And with geometry, it's not only the asphalt varies, but also where exactly the vehicle stops, where are detectors placed, etc. Then the interaction of individual road users. And this is important. A microscopic, so looking at individual vehicles, you should be able to replicate phenomena which leads to traffic breakdowns, because often you want to know what is the maximum throughput. So there could be acceleration, deceleration, lack of attendance, some lane change issues. And then also you can include the signal timings, like in the field. It is normally only approximately doable in a macro model, but there you can really react also actuated public transport priority is something you can do. And a little bit further, the cooperated intelligence transport system can be considered, ramp metering, variable speed limits. And then what I underestimated is the presentation. So, and that helps very much the communication and explain the model to decision makers. Here's an example from Vissim. So the level of degree you can go, you can produce that. As I said, I underestimated that, the importance of that. So we see a lot of videos like this being shown, and there's certainly a value explaining the model, explaining the designs that supports very much for decision makers. And then also in microsimulation is again what is needed as an outcome. So replicate some phenomenon. Let's teach a traffic breakdown, and that's an example what you see here, and you have this detailed analysis in performance measure, maximum throughput, travel times, delay times, not only aggregated but also distributions of them, number of stops, queue length, discharge rate at signals, that is often important in urban areas, localized emissions, so not link level emissions, you get them you identify hotspots, and then also detailed protocols. For example, if you look at green waves, design them from different approaches, they are microscopic simulation problem. So I hope I could give you some overview why typically you use simulation in general, and specifically then also what are advantages of microsimulation. Thank you.
Thank you, Jochen, for your presentation. I think that we have some question in the chat from Marilo. So maybe Marilo, can you just jump in and maybe a question?
Sure. Yeah. So, well, my question is, I really like, and I'm gonna, in fact, use my words there, that congratulations, Jochen, for such a great presentation beyond what is just microsimulation in Vissim. So I have a question, because you know that we are a little bit involved into that in Spain. So for professionals working in countries where there is no an HCM, highway capacity manual for that country, could you consider that there is exactly the place where microsimulation fits and should be accepted and used?
No, would be good for our business if we do that. So, but as I said, it's about the cost benefit. And for staying on this example on the roundabout, even if there is no analytical methodology in place in a country, I mean, you shouldn't do a microsimulation. It's just too expensive to do that. You just need to rely on other data. I'm not sure. Maybe rely on other experience, some adjustments maybe from the HCM to make it localized. I'm not the expert in these analytical methods, but there needs to be a way. I mean, microsimulation is often not really needed to make a proper decision. Even though that's my field and I like to see more and more microsimulation, but we also need to look at the cost benefit of these projects.
Okay, so then, yeah, my second question doesn't fit anymore, given no, because my second question following in that one is like, yeah, you also considering the unknowns and everything that you explained in those slides, we know that there are some professionals that might not be like, they are still in the learning curve, so it can be not saying bad calibrated, but no proper calibrated models. So then my question was like, then if we want to start to introduce in those countries much more microsimulation, not only saying VISIM, but specifically for sure VISIM, but how we recommend to those governments, to those organizations that they control those projects, that there is a point where analytical models may not work. Please try to use microsimulation to see.
Yeah, maybe to add there, you raised a good point, which I missed in my presentation. Microsimulation can also, or simulation in general, can help you, of course, educating to gain knowledge in traffic fundamentals, in understanding problems. That is also, of course, an aspect.
I love it. Being in academia and research, I love it. Okay, that's it. Thank you, Ignacio. And thank you, Jochen.
Thanks, Marilo. We still have another presentation, last one of this workshop. So we now count with the participation of Didier Scellier. As I have already presented him, he's Managing Director for PTV France and also for PTV Iberia, what make him my boss. But also an expert in the field of decision support tools for the logistics sector. Didier will tell us about the current developments of PTV in this matter. So please, Didier, you can proceed with your presentation.
Hi, Ignacio. I hope you can hear me very well. And thanks for this introduction. So I'm very happy today and proud to speak about logistics and transportation. And I try to show you how PTV support the actors of logistics in order to help them in the planification and optimization of their mobilities. So I'm Didier Scellier, the Managing Director of PTV France and PTV Iberia. These responsibilities cover 4 countries, France, Spain, Portugal, and Andorra. And in all these countries, we have several customers, but also partners which use every day our technologies to solve and propose solutions for logistics and transportation companies. Okay, so what are we doing at PTV? For sure, you already assist at several presentations. What we say, we provide solutions and also services to plan and optimize everything which moves people and goods worldwide. So we are located all around the world. You probably you saw during the previous presentations what we are doing for mobility of peoples. You probably also know very well our solution for this domain. In my presentation, I will focus on planification of goods and mainly the planification and optimization of deliveries inside the cities. I try to show you what are the challenges and what are the solutions to solve all the challenge. Urban logistics is vital for sure for operation of a city as well as well-being of its citizen. The logistics sectors involved face serious challenges intensified by increasing urbanizations. The latest actuality regarding the coronavirus also increased the intensity of the demand on logistics and transportation to help and to provide and deliver all the needs and requirements from end customers. Just have a look at few figures. We consider that 55% today of the world population living in the cities, and the estimation are 66 for the end of 2050. So it's a very sensible information and figures to well understand how the pressure of logistics will be important for the next years. 28% of total cost of transport is also cost to the last mile. There is no real now big constraints regarding the travel and the optimization between long distance between 2 points, and all logistics is already well organized to provide the depot in the region and around the cities. But the last mile is a real open questions for all logistics and transportations company regarding the cost linked to these constraints. We also know that 20% of traffic is for goods, and it has an influence of at least 50% of congestion cases. So we also know with these figures that we have a lot of things to improve. The main pains for the companies are the real life, and the real life is composed of uncertain variables. That's why the operators needs to solve several functional issues. The first one, probably the biggest one, is the geocoding. How can I find exactly the position of a delivery point from an address, which is normally right by peoples, and not really always well right. So I have just a text on how can I convert this text in a real positions in order to support and be sure that the driver during the delivery phase is able to find as fast and as easy as possible the location on the point to deliver. The second functional issue, which is also very important, is sequencing. Sequencing has to answer to the question, how can I organize a trip to deliver all parcels respecting the customer time window, and also reduce as much as possible the distance and the pollution, for sure. I have a set of points, more and more points has to be delivered by one truck, and how can I reorganize this trip in order to be sure that I can respect all constraints on my trips, respect that this customer has to be delivered before 8 o'clock and the other one between 1 and 2 o'clock, and how to ensure that the distance is well optimized in order to reduce for sure the cost, but also to reduce the impact on the environment. The third functional issue we have to solve concerns the execution. The word ETA signify estimation time at arrival. So the question is, how can I know the estimated time at arrival to guarantee the customer satisfaction and react in real time with the hazard of traffic? We know that the city can move and can change every time, and how to give the tools and hold the algorithm able to support the operator to reorganize the tour when something's wrong appears during the trip. And the last but not least also concerns the sectorization and optimization. Regarding existing activity based on historical data, and also knowing the workload, how can I reorganize my territory, select the good vehicles for optimization, also reduce cost, distance, and pollution. Sometimes you have a good history of activity and you have a huge data set. How can I reuse this data set in order to define which kind of vehicle I really need to deliver my workload? All these features for sure are expected with a high level of performances, because we speak about operational use mainly, and we speak about execution. So we need a real high performance system, a constant availability, because when you have to prepare the delivery of 80,000 parcels during the day, you can't take any risk, because if you can't deliver these parcels the current day, you have to deliver the next day with the whole the parcel of the next day. So it's very hard to re-optimize. And for sure, we must be able to take in charge huge volume of data sets, because often we have to take into account a lot of constraints, a lot of parcels, and we have to combine all of them in the same tools. With the next slides, I will show you how we can fix these issues and provide to the operators the best solutions for the improvement of their activity. PTV proposed solutions as part of the three main critical steps for the urban deliveries. First of all, that concerns the strategy. Strategy is a solution for the organization of the territories, identification of the best tracks, optimization and reductions of the impact of the transport on the environment. So we are not in the operational use. It's a kind of study. Okay, I know what I have to deliver, or of what I delivered the last year, and I would like to take it into account to consider or to analyze if my fleet of trucks is well adapted for what I have to deliver, and how can I reorganize my territory in order to reduce, for sure, the cost, the distance, and the pollution of my activity. This is generally standalone solutions just to support engineer to think about logistics and optimization of the activity. The operational use is a little bit different, because we are in immediately the solutions are used by operators. Solutions are used for the preparation of optimization of the tours day by day. Generally, the system is used the morning, few minutes before the departure of the vehicles, taking into account what is ready to be delivered. So generally, companies know more or less one day before and as the last time what they really have to deliver, and they need system in order to reorganize, reoptimize, and planify as fast as possible which kind of trucks can I use, and how can I optimize the tour. During the operational use, we can also take into account if a driver is not available, how can I, if the truck is broken, how can I replace regarding the change of the fleet, and how the system can reoperate and send several requests to algorithm in order to reoptimize the tools. Execution, as I said the slides before, is a solution for track and trace. The idea here is to offer a solution to react with hazards and calculate in real time the estimation time at arrivals. The ETA is very important to ensure that the delivery point will be open and ready for the reception of the parcel. One of the big pain for the logistics and transportation company is to be sure that when they arrive at the destination point, the people concerned by the delivery are here, because if they are not here, the parcels came back to the depot, and it has additional cost for the transportation company for sure, but it has also an impact on the organization of the transportation company, because these parcels has to be redelivered the second day and could have an impact on the organization of the tours. So the ETA is for sure at first for ensure the quality, the customer satisfaction, but also ensure that the delivery point will be open at the arrival of the vehicle. All of these solutions are based on a centralized platform. PTV provides several technologies, also called web services. The technology can be deployed on site in accordance with the expected performance and depending of the use case. First of all, let's have a look at the main issue, localization of the recipient, where I have to deliver. Sometimes I have only an address, which is a text. A text can be easy understood by the driver. When you have a text of the name of the street, you have a system able to convert the name, PTV solutions able to convert the name of the streets into a position. And if the name is not very, very clear, or if the position is not exactly at the good position in the street, for the driver, it's easy to find the house, because when you are in your truck, you are in the streets, and if you just have a number and you are in a good street, you will have no huge effort to do to find the good entrance of the house. Regarding the cities, it could be really different, because sometimes you can have the name of the street here and just the number of a building and a number of an apartment in the building, and sometimes it's more difficult for the driver to find exactly where he has to deliver. And with this example, we can imagine how it could be stressed for the driver to say, okay, I have to stop my truck here, and where is the entrance of my delivery point? It can occur several stress. For sure, in other areas, it could be more complex, because you can, for example, at La Défense, you can have just one street, or the name of an area and the name of a building, and you don't really know where is the building. You just have the name of the streets, and sometimes it can occur several problems and several pains for the driver. And the last, and probably the most difficult things, is when you have only the name of the retailer in a big industrial area. You just have the name of the retailer, and you have no name of the streets, you have no name of the parcels, and you have to drive and find where is the entrance of the retailer, and you can imagine how it's difficult. To solve these issues, PTV developed technologies of geocoding, including the analyze, and not only analyze of one positions, but taking into account several positions. Our technologies are able to consider the address point. The address point is a position of your address and your address number in the street. It's not really the entrance of what you have to deliver. It's just an administrative address, but it's a first indication of where you have to go. And we are able to link this address to the network. And it's a first nice entrance for the transportation company. Second position, take into account, this is the entrance of the building, localization of the entrance. When you have a look at the picture, at the screen, you can see here 2 points at La Défense. It's a real good example. You have a tunnel here, and when you take the name of the street, if you consider the position of the street, and you have a tunnel here, and you have the entrance of the building, which is on the other side of the tunnel. And if you consider only one position, you can imagine how it could be complicated to say, okay, to know or identify if I am exactly linked to the street here, or if I have crossed to the tunnel, and where is the entrance is something which will be really hard to solve automatically. So that's why we are able in standard approach to consider here this position in the street and also the entrance of the building. And we are also with our companies and customers to add the position from tracking system. Position from tracking system is just to record when a truck delivers some things at this location, we just take into account where the truck was stopped. In this case, we can say, okay, we have this position is the administrative position of the address. We can consider if the truck was parked here, where the truck has to be parked to deliver this point. And we are also able to take into account the position of the entrance of the building. And with these three positions, we are able to produce or to reuse the best to implement. For example, we can reuse the entrance of the building for navigation. We can use the administrative address for optimization and so on. And regarding the use case, we are really able to use the best positions. Sequencing and optimization is also not something easy to solve. And that's why we developed since more than 40 years. A lot of algorithms able to re-optimize the trip, not only taking into account the position of what we have to deliver, but also taking into account a lot of constraints. I just put several examples here. Time windows, as I said in the previous slides, it's something really important because the transportation company has to know as well as possible where the customer is available to receive the parcels. And also for sure, all logistics constraints, which kind of materials is transport, to know if which truck is compatible with the parcels, how many stops can I do for my trips, what is the maximum distance and duration for a trip, etc., etc. And for sure, all this algorithm take all the parcels, take in charge your fleet, and reorganize the tours, not really using a flying distance, but the real roads and the real driving time between each points to be able to reorganize the tours, taking into account all the constraints. As I said, we are really able to take a lot of information. As you know, the drivers in Europe has several constraints for working time, and they have to do breaks, legal breaks after 4 hours of driving, and all these constraints for sure can be taken into account by our system in order to prepare the best tour able to be produced by the drivers. Optimization can be really efficient if we were not able to take into account the traffic information. And traffic information has a big incidence in the optimization results if we speak about urban logistics. We are working with 2 dimensions. We are able to work with 2 dimensions. The dimensions only time. We consider, for example, between 2 points, the same trip, the best trip between 2 points, and we just analyze the difference of time regarding at what time you are doing your trip. We don't change the distance, just the time, taking into account the traffic in order to planify the delivery as best as possible, also regarding the traffic information. We also have the possibility to modify the distance between 2 points and say, okay, this is not the best trip between these 2 points because of traffic jam. So we consider this new trip to deliver or to take into account the distance and time between these two steps, or these 2 stops. Often the companies prefer to maintain the best trip and just take into account the impact of traffic because to consider that the driver is always on the best trip and just manage the impact of the traffic on the tour. Estimation time at R-Evolution is also an important thing because we have to not only manage the historical data for traffic information, we also have to take in charge or take into account the real time, the traffic in real time. Also considering accident, considering exceptional traffic jam, and so on. Like this, we can really inform in real time the delivery point, which could be a company or a depot or just a consumer, at what time the parcel is expected. Like this, instead to stay at home all the day to wait your parcel, you can just receive a short message and say, okay, we will be there between 8 and 9, and please confirm and just inform us if you are not here. And all this time, or the arrival time, is calculated by our server, taking into account a lot of information, including the real-time traffic. So sectorization and optimization is a pure strategic analysis of the data set, historical data, in order just not to promote and to re-optimize the tour on existing territories, but just think about what could be the best fleet of trucks. If I have to switch from standard trucks, fuel trucks to electric trucks, what could be the impact in my organization, how parcels I will be able to deliver, and so on. This is an important tool in order to rethink about the activity and logistics activity for big players. For sure, we have, when we speak about urban deliveries and urban logistics, we also have to take into account several things. It's a big combination of uncertain variables to know if I have to use trucks, cars, or bicycles sometimes, electric bicycles, pedestrian deliveries, where can I park my truck, where is the best to stop my truck and deliver, I don't know, 5 or 10 points with a one stop. All of these questions can be also addressed and solved with our technologies. Just one example, between 2 points here. If you consider you have to take your truck between these 2 points, you can imagine the trip you have to do with your truck in order to deliver these 2 points. But sometimes it's better to say, okay, you have to stop your truck here in this street and go by foot to deliver the other points, come back to your truck and go to the other point. And you can save for short time, but also fuel and reduce your emission. So I spoke about availability. For sure, we need very high performance routing and high performance calculators, and that's why PTV put in place a centralized platform based on web services in order to provide to the big players high performance calculators to solve all these issues with a high level of availability. Just for a few examples, we are able to geocode in 25 milliseconds one address, so it can really be done in real time because sometimes the driver with his mobile application just send a request to the server and want to know where are located all the addresses, and for sure re-optimize as fast as possible.
So sorry, Didier, for interrupting you, but we should be finishing. Yes.
Yeah, it's just my last slide. Okay. Just few references we have. Just when I spoke of big players, for sure, and when we spoke about parcels, you can find the big players like DPD, DHL, and the other one. And tomorrow, for sure, what are the future of optimization and planification, and what PTV is looking for we are discussing with transportation logistics providers to speak about commodality, to use and optimize the infrastructure and share for sure the use of existing transportation solutions in order to combine between several companies. Instead of 2 trucks with only half load in the city, it's better to have only 1 truck. So why not share the trucks between several companies? And also, why not share the use of the existing infrastructure to adapt the delivery in the city center? And it's what we are working with the big players and big logistics providers. And the last one is for sure to think about new infrastructures like underground networks, air networks, channels, and several initiatives and things. We are part of several research and developments program to work on innovations like city hubs, autonomous vehicles, robots, and drones to identify how we can reduce the impact of the trucks in the cities, and also take it into account in our infrastructure. Yeah, it was my last words, Ignacio.
Thank you, Didier. Yeah, I'm sorry for getting,
no problem.
but yeah, we have run out of time, and I'd like to give room, not for questions because I don't see any questions, but for the break, because there is another session after. There's another workshop of PTV, the PTV, so-called the PTV Talks Students Edition. So I would like to close here this workshop of PTV Shaping Mobility in the CIT 2021, agradeciendo, I change again to Spanish, vuestra atención a los asistentes y especialmente la participación de los ponentes, de Luis Willumsen, de Sebastian Silliman, Jochen Lohmiller y Didier. Y espero que haya sido de interés y realmente, bueno, hemos agotado el tiempo que teníamos dedicado. Gracias también a la organización. Con esto cerramos la sesión.